Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to study the moment of a force, the concepts and its applications, what is the principle of moment of a force, and how to calculate the moment of a force, what is the law of moments we are going to study in this class. Let us begin. What is the moment of a force? So the moment of a force, the concept of a moment of a force begins from the system of a forces. When there are two types of system of forces. Number one, it is coplanar force system, and second category is non-coplanar force system. In the coplanar force system, in coplanar force again there are various types. One of the type is coplanar concurrent forces, and second one is coplanar parallel forces, and third one is non-parallel forces, and next one is the collinear force. Coplanar means the meaning, the word itself gives the meaning that describes. Coplanar means it's the same plane. Concurrent forces, we have studied in previous sessions. When coplanar concurrent forces, the concurrent means the various forces are acting at one point. It's the point A. So F1, F2 and F3 are acting on a particle or on a body. This type of force system is known as coplanar concurrent force system. We have calculated the resultant of the coplanar concurrent force system. When more than two forces are acting on a particle, we have to use the concept of resolution of the forces. And by using the concept of a resolution of the forces, we divided the force F1 into horizontal and vertical component, F2 into horizontal and vertical, F3 into horizontal and vertical, rectangular components. After that, then we divided this all horizontal and vertical components into two categories. The value of all horizontal components, that is sigma h equal to, that is algebraic sum of all horizontal components, and sigma v, algebraic sum of all vertical components. And we found the resultant force by taking the equation, the expression of sigma h whole square plus sigma v whole square. Sigma h whole square plus sigma v whole square are equal to sigma h whole square plus sigma v whole square under square root of sigma h whole square plus sigma v whole square. This R is the resultant force, the magnitude of the resultant force R. What about direction? The direction theta equal to tan inverse of sigma v by sigma h is the direction gives. So far we have covered and this. What is the resultant force of a coplanar concurrent force system? Suppose when two forces are acting on your body, only two forces are acting on your body. Suppose if P1, P and it is the Q. What about the resultant force on a particle A? The resultant force P and Q is or can be calculated by using Parallelogram Law of Forces. So the Parallelogram Law of Forces R, it represents the R. Alright. The P and Q, that R gives the distance from diagonal distance. It represents the resultant force of P and Q. So the Parallelogram Law of Forces states that when two forces are acting on a particle, the resultant of that force is the diagonal of the parallelogram, because provided these P and Q are representing the two sides of a parallelogram, and the length of the diagonal of the parallelogram gives the value of the resultant force of a system, a coplanar force system, when two forces are acting concurrent at one point. So this parallelogram law of forces we calculated by using the resultant of a two-force system is calculated by using parallelogram law of forces. Now, we want to find out the resultant force of a parallel force system, coplanar parallel force system. If you want to find out the coplanar parallel force system, what is the meaning of coplanar parallel forces? All the forces, coplanar parallel force system, all the forces which acts parallel to each other. Then how to find out this resultant? Suppose it is a beam, a fixed beam. How to find out the resultant force? Or if the number of forces are acting on a body which is some parallel to each other, how to find out the resultant? Then we have to go for, we can't apply this parallelogram law of forces and the way concepts we applied for the calculation of the resultant of a coplanar concurrent force system. So in this class, in this session, we are going to study the coplanar resultant of a coplanar parallel force system. But here, the forces, parallel forces means the forces which are acting on a body doesn't intersect at one point, which are parallel to each other. In this case, if you see, all forces are acting in the same direction. That's why this force system is known as coplanar like parallel force system. Suppose if some of the forces are acting upward direction and all forces are acting, all are not in the same direction. Some of the forces are acting upwards and some of them are downwards. So these forces are known as, the type of system is known as coplanar unlike parallel force system. Unlike parallel force system, that is the category here. So what are the characteristics of coplanar parallel force system? So the first characteristic is that all the forces, the line of action is parallel to each other. And the second characteristic is that the two parallel forces will not intersect at one point, at a point. It is not concurrent point. It is a parallel at different points. Two parallel forces will not intersect at the same point. That means it will be at various points. So if it acts at the same point, it can't be a parallel, it becomes a concurrent. Then the resultant of two coplanar concurrent force system is directly determined by using the method of parallelogram law of forces. The next, the parallel forces are having their lines of action parallel to each other. And the third characteristic, how to find out the resultant of these two parallel forces. So the limitation is that for a parallel force system, for finding the resultant of two parallel forces, we can't apply parallelogram law of forces, or parallelogram can't be drawn when two forces are acting parallel to each other. Okay, so that here parallelogram can't be applicable. Then which law is applicable? So the resultant of a coplanar parallel force system can be calculated by using the principle of moments, or by applying the principle of moments, we can find out the resultant of a coplanar parallel force system. So principle of moments, first of all we have to know what is the moment. So moment means the distance, the product of mathematically the moment m equal to force times distance between from the action of the force to the point line of action, or any point, arbitrary point. Now if we consider here the moment of a force about the point O, what is the moment of a force about the point O? Is the product of the force and the perpendicular distance of the line of action of the force from a point is known as the moment of a force, that point. For here, the figure 1, the moment of the force F is the force which is acting. what is the distance to the action, that the perpendicular distance is the d, that the moment of a force m equal to F times d. D is the distance between the line of action force to the point, but the distance should be perpendicular. Here, the moment of the force, if you see from this direction, the moment of a force is F. F is the force and perpendicular distance is the distance, if you understand, the distance point. So when it is acting, what happens? The moment of the force causes the rotation motion of the body. The effect of the force of a movement is rotation, rotary. It causes rotary motion. Now, in the figure 2, we can see the line of action of the force. The force is acting on a body here and the point O. This from O to the line of action of the force is the distance, that is the distance is R. What is the moment of force here? What is the moment for this figure 2? The moment for figure 2 is F times radius. Here F times R is not radius, it is the distance between from the line of action of the force to the point where we are going to find out the moment. Alright? Now, if we consider figure 1, we can understand better the direction of the principle of moments. Okay, what is the moment axis? If you keep the right hand on the moment, the direction, if we place the direction of the force in this direction, from top if you observe, in this figure, the direction of the force is, from top it is anti-clockwise direction. Now, what is the moment axis? The thumb indicates the axis of the moment. Okay. F into D is acting. This is the F times D. The D is here. It indicates what? 90 degree. It is the normal. The distance. The what? So, what is the moment axis? The direction of the moment axis is upwards. But there is one more thing. What is the direction of the moment? There are two types of moments. One is clockwise movements and the one is counterclockwise movement or anti-clockwise movements. But here in this case, the F is acting such a way that on the disc, it making to rotate in which direction? Counterclockwise. So, coming to next. F equal to, what is the F? Let F equal to a force acting on your body. Here in the figure 1 I mentioned, force acting on your body. And what about R? R is the perpendicular distance from point O on the line of action of force. Point O on the line of action of the force. This is the R. And what about F? It's the F. Then the moment M, the moment M of the force F about O equal to M equal to F times R. Moment M equal to force times F times R. Now, what is the effect of this force? How can we know moment acted? So the tendency, what is the tendency of this moment? The tendency of the moment is that to rotate the body either in clockwise direction about O. If the tendency of the moment is to rotate the body, if it is in clockwise direction, then that moment is known as clockwise moment. And if the tendency of the moment is to rotate the body in counterclockwise direction, then it is known as the anti-clockwise moment. It is not a movement, M-O-V, it is the moment, M-O-M-E-N-T, okay? It's the anti-clockwise movement. So, the sign convention of the moment is, if we consider the clockwise movement is negative, taken as negative, then the opposite direction, that is anti-clockwise movement, can be considered as positive. If clockwise movement is taken as negative, then anti-clockwise movement will be positive. Or vice versa. If you consider clockwise movement is positive, then anti-clockwise movement you have to consider it as negative. Alright, now in the before figures, you can understand here. In the figure 1, if you see the causing, the tendency of the movement is rotating the body in anti-clockwise direction. That's why here it is anti-clockwise movement. So anti-clockwise movement we consider as positive. Okay, or if you consider negative, then clockwise movement we have to consider it as clockwise movement should be considered as positive. Now here the anti-clockwise movement is considered here positive. Now in the figure 2, if you understand the direction of the movement, the direction of the force, here it is F, it is causing to rotate in which direction? Yes, clockwise direction. So the clockwise direction, this movement is known as clockwise movement. Clockwise movement is considered as negative. So the direction, the sign, the effect of this clockwise movement is considered here it is negative, then anti-clockwise is considered as a positive. So these are the two types of movements, clockwise movement and another one is the anti-clockwise movement. So further understanding the movement, as we understand that, what is the moment? It is the rotational effect of your force. The moment is the rotational effect of your force. Mathematically, moment equal to the force multiplied by the perpendicular distance between a pivot and the force. The pivot and the force, it should be perpendicular distance. The perpendicular distance is not some inclination. Neither acute nor obtuse distance. It should be having exact normal distance. That causes to rotational movement. So the effect, rotational effect of your force is known as the moment of your force. The tendency of your moment is causing what? Rotation. We learn more explanation about in relation to the applications of the moment of your force in day-to-day applications. Suppose here the applications, examples of a moment of a force, if you are opening or closing the door. If you are opening the door, either you have to push or another direction is the pull. Suppose if you consider the door, this is in direction here. If you push the door in this direction, is the pivot point. At one end is the pivoted, is the force F. When what happens, the door will be moved to this position. So the force and the perpendicular distance. Here what is happening, the force, if you push the door and pivoted, the door is pivoted at one end. The door causes such a way that what has happened here, it is moves in the direction. From top view if you see it is rotating in counterclockwise, it is rotating in clockwise direction. It moves rotary in rotation. That's why the rotational effect of a force, that rotational effect is not only alone force, it causing what? Force times perpendicular distance, F into D. That rotational effect is caused by, what? The word is known as the moment. Moment of a force. So opening of the doors or closing of the doors, the concept behind this opening and closing takes place because of the moment of a force. Now, and it is causing what? It is turning. That's what the turning, a moment is the name for the turning effect that force exerts on objects. That force exerts on objects is known as a moment. The turning movement, wherever you are applying turning movement, this concept you can apply because of the moment is the name given for the turning effect that force exert on the objects. Now, as I mentioned here, the example is that pushing a door open. So you push on the door handle and the door rotates around the hinges. The door is rotating around the hinge. This is the hinge point. Okay, around the hinges. This hinges is known as the pivot. The pivot means fulcrum point. The pivoted means hold it at one point. Suppose it is not pivoted, what will happen? If you push the door falls down. So the point is that This example helps. What is that example? The moment of principle will apply for opening the door or closing the door. And another example is that, so further here, in order to explain more, so we exerted a force that caused the door to rotate. The rotation was, why it is rotating? It is being rotated. The cause of the effect, the cause of the rotation of a door is the resultant of a moment of which force? The pushing force, of your pushing force, that makes this force affecting to rotate the door. That, what is that affecting the rotating the, that phenomena, that concept, the principle of moment acts. The principle of the moment, that force causing to rotate the door. This is that rotating the door is not the turning effect of the door is known as the moment. That's what. So here the pushing a door or pulling a door to open or closing, it is very much helpful to understand the concept of the movements. Next one more thing is that the location of the door to handle, how will we handle? Okay, suppose it is on the opposite side of the door to the hinges. Think about the location of the door handle. The location of the door handle is on the opposite side of the door to the hinges. Side of the door to the hinges. So the reason for that, it is the moment of a force is related to the size of the force and the size of the perpendicular distance between the force and the pivot. So the larger the perpendicular distance, the larger the turning effect. That means moment. And if it is the smaller, the point of application here it is, you can understand here. From this figure, the door is hinged at this point. If the distance is the shorter, the larger the pushing force you have to apply. Alright. If you want to opening the door from the pivot to distance, this is the pivot at this end. So if you apply the force in the pivot, you need more force to rotate. If you're going, if the edge, if you apply here, suppose you'll understand better in this direction. Here, this is the hinged end. If the force is this end, the force required is lesser in compared to if you apply the force near to the pivot end. Okay, so the larger pushing force is required when the distance, the perpendicular distance is smaller between the action of the force and the pivot point. And if you push the force here, the larger the distance, the d is the distance here, d2, and here it is d1. So the d1 is lesser than, smaller than d2. So d2 is the force. D2 is the distance, not the force. D2 is the distance between the line of action of the force to the pivot. When D2 is applied here, the D2 need, because the larger the distance, how much the force? Smaller force. The smaller force, if you consider Fs, and the larger force Fl. So here D1 is greater than D2, D1 is less than D2, or you can say yes, then Fl, whatever larger pushing force, this Fl is greater than Fs. So one more thing, is this forces are acting clockwise or counterclockwise towards about the pivot point? The forces which is acting towards the pivot point is, you can understand this is which direction they're causing the effect. It is in counterclockwise movements. These forces are giving counterclockwise movements about the pivot. Okay. The next one. Consider the figure here. There are two forces are acting in this before the diagram. Here, there in the diagram, there are two forces F1 and F2. we can find the moments of both the forces by taking moments about the pivots. Alright, where the other forces are acting. Suppose here there is no pivot here. We are considering the moment of the force F1 and D. That means F2 point 2 becomes pivot. What is the cause of the moment caused by F1? That is F1 times D. But that when F1 into D, that means pivot is the point 2. Now, this F1, the action of the line of action of the force, and D is the perpendicular distance, is the 90 degree. So perpendicular distance. If we consider the F2 force, the F2 force is not like that. This F2 is making an angle, certain inclination, which is some angle. But the concept of, or the expression of the moment, that means force times perpendicular distance. If we consider that the angle between the D and F2 should be 90 degrees, that means normal to each other. But here in this case is not like that. So what to do here? We have to apply the resolution of a force. The resolution of the force, in that case, what will happen? Here it is theta, then vertical component becomes F2 sin theta. So if we consider the moment of force F2 towards the point 1, then point 1 becomes what? Pivot for couple the F2 force. So for that case, F2, what is the moment caused by F2? That equal to, what is the force? The line of action of the force, this is now F2 sin theta. F2 sin theta times, what is F2 sin theta times? D. This F2 sin theta is known as F2V, vertical component times distance D. This is the moment of a force caused by the F2 force. And this F2 force is giving what? Clockwise movements. The clockwise, and F1 force also giving clockwise. So what will happen here? If there is a fulcrum point here, or if there is a hinge point, then what will happen? This F1 and F2, it causes to rotate. In which direction? Clockwise movement. Clockwise direction. That means F1 and F2 sin theta, F1 and F2 sin theta, causing to rotate the body in clockwise direction, causing to rotate. That means moment is the cause of rotating the body. Okay, that's what here the moment of the force. Now, this is the figure we have studied already. Once again, we need the concept of F2 times the distance D. The direction between F1 and D should be 90 degree. That's why F1 times D, that is one of the component movement, and F2 sin theta times D, F2 sin theta. This F2 sin theta is nothing but what? F2V, F2's vertical component. This is what here it is mentioned. So F2V, that is called moment, equal to moment caused by F2 equal to F2V times D. This F2V, yes, why it is? F2 is not perpendicular to D. Okay, now this F2V equal to what? F2 times sin theta. What about F2H, the horizontal component? This F2H, what is the cause of this? F2H equal to F2 cos theta. So what about the effect of F2H on this? It doesn't affect, okay, to moment of a force, the rotation effect. So the F2H doesn't affect to cause the rotation of the body. But which component is affecting to making to rotate the body? F2V is causing to rotate, that is F2V sin theta. This F2 sin theta is making to rotate the body in which direction? Clockwise direction. So that's why the F1 and F2 are causing clockwise movements on the body. Now, there are various applications. What are the applications? of this moment. Here we are going to mention there are 10 applications. The first application of a force, that means the turning effect of a force refers to what? The turning effect is known as the torque. This rotational is rotational analog of a force. That the effect of the rotation is caused by the moment of a force. Okay, the moment, that means where is the rotation? That is the torque. So this torque helps to open and close the door. And also torque helps us to not only doors, opening and closing of the caps. If you have here the opening and closing of a cap, how can you make it? Here it is. You may tell that where is that? Where is the direction? In this direction and perpendicular distance. No, we are holding the force normal to that and causing to rotate, about which it is rotating, about radius of the screw. Okay, it is causing to rotate. That is also movement. This is the torque force, twisting movement. Now, and also the concept of movement helps to unscrew the nuts of your vehicles, four-wheelers and two-wheelers. So when the wrench, we are going to see that in picture form here. If you want to nut and bolt, remove the nut and bolt with the help of your wrench system. The wrench system is such a way that the wrench system is such a way, if you want to cause the rotation, the wrench, you mean which direction you are giving, you are causing the force, either tightening the distance from pivot point to the way of action. This F into D causes to either tightening and unscrewing. Okay, this torque helps or moment helps to rotate. This F into D is the moment of a force. Moment F, moment equal to F times D, where F is the action of the force, magnitude of the force, and D is the distance between the line of action of the force and the pivot. Okay, next some of the applications regarding this moment is that vehicular engines apply torque and rotate the axle connected to the wheels of the vehicle. That's what screwing and unscrewing of the nuts. And one more thing, very simple example is that if you want to sharpener, we are rotating the pencil inside the sharpener. That is also one of application of a moment. And torque is also needed to rotate the steering wheels. If you want to rotate the steering wheels, this is torque. Torque is nothing but a moment of a force of the car. So this rotary force is applied by, this rotary force is caused by what? Which force? Which one? By our hands. The torque. And the torque is needed, very important, torque is needed to rotate and open the door knob as to act as the open the door, yes. And children apply torque while riding seesaw in parks. Seesaws, have you seen the seesaws? This is the seesaw, and one side children's. Okay, this is a seesaw causing to rotate. This is the torque caused by. We are going to find out this is the D1 and it is the D2, and here it is F1 and it is F2. So the motions, we may think that is upwards and downwards motion, but if you see towards the fulcrum, it is a rotary motion. The rotary motion is caused by the moment. This rotary motion F1 into D1. So when these two people will be, when in horizontal becomes horizontal, when F1 into D1 equal to F2 times D2. The clockwise movements, one of the force is the clockwise movement. So here it is, which direction? Counterclockwise, anti-clockwise. What about this direction? Is the clockwise. So clockwise movements equal to anti-clockwise movements. F1 D1 equal to F2 D2. Then it will be in moment equilibrium, no rotary motion. If F1 D1 is greater than F2 D2, if F1 D1 is greater than F2 D2, what will happen? The person A comes down, and the person B, here the person B moves up. If F1 D1 is smaller than F2 D2, then what will happen? The F2 B person moves down and A person moves up. So if you want in equilibrium F1 D1 equal to F2 D2, that means this is called law of principle of movements. We are going to study further in detail. Now, here we explain here in relation to the torque application, that means moment application while riding seesaws in parks. Another one is that work applied force to spanner and rotates a part of any machine. If you want to tighten the screw, the spanner, if you keep such a way that what will do, will apply the moment, the torque you will apply. The torque means what? Force into perpendicular distance. So these are the few examples of a moment of a force. Alright, in this session we have studied what is the concept of moment. First of all, begin with the coplanar parallel force system. How to find out the resultant force of a coplanar parallel force system. The resultant of a coplanar parallel forces can be found by using law of moments. Then what is the moment and what is the formula expression of the moment and what are the application of the moments are studied in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.